Hello and welcome to this quick take video where we'll be discussing how to use incremental compile flow for faster debugging of implemented designs. Here's what we'll learn in this video. We'll look at the purpose and benefits of using incremental compile flow for debug, the required steps for debug using this flow, and a demonstration on how to use the tool to perform these steps. Incremental compile is an advanced design flow used for designs that are nearing completion, where only small changes are required. After resynthesizing the design with minor changes, the incremental compile flow can speed up placement and routing by reusing results from a prior design iteration. This faster place and route runtime depends on the amount of changes applied to the design. For example, if there is 5% change in the design netlist, it is possible to have a 2x faster implementation time. On the other hand, if there is more than 25% change in the design netlist, the default non-incremental place and route will be used during implementation, and there will be no runtime improvement. In addition to runtime improvements, incremental compile can preserve QR predictability by reusing the prior placement and routing from a reference design. As noted, the flow is most effective when synthesis changes result in at least 95% similarity to the reference design. One of the advantages of using incremental compile is the ability to change the debug setup for a design that has already been implemented. This change happens after synthesis, where new cores get added to the design for the first time, or those that have already been added are modified or removed. Now let's look at the steps involved in using the incremental compile flow for debug. First, we need to identify a reference design, which is usually an earlier iteration or variation of the current design that has been synthesized, placed, and routed. This reference design checkpoint guides the incremental compile design flow for subsequent place and route runs. We can point to this reference design checkpoint in implementation settings when in project mode, or use the read checkpoint -incremental command after op design in non-project mode. The next step is to go to the post-synthesis result of the current design and apply all of the desired debug changes. We can use the same available methods. For example, if insertion is used, we can use the setup debug wizard to add, modify, or remove ILA cores. And if instantiation is used, we can reconfigure the IP, change connections, and resynthesize the whole design. Only after making the changes post-synthesis, it is time to rerun the implementation, which is done incrementally and faster if the changes are within the allowed threshold. Let's see how it all looks in practice. The example design we use here is a netlist-based project. It has a synthesized design as a source file along with a constraint file. The constraint file only contains the timing and physical constraints and has no debug information in it. This design has been implemented in project mode using the GUI with default flow, which is non-incremental. As you know, project mode generates and stores implementation results and supports the creation of multiple runs to configure and explore available constraint or command options. However, if you were in non-project mode, you would use tickle commands to compile a design through the entire flow, so you must manually manage source files and checkpoints. Despite that, the concept of the required steps to use the incremental flow is the same in both modes. If we open the synthesized design, it also shows that no debug core has been inserted or instantiated in this design. For using incremental flow, it is a required step to reopen the synthesized netlist in order to add, delete, or modify debug cores. But it is not a requirement for the design to already have a debug core in it. But for the purpose of this demonstration, we selected this design that has no debug core in it. In general, we can use either insertion or instantiation flows to add or change the debug cores. However, since this is a netlist-based project, we can only use the insertion flow. Let's use setup debug wizard to add an ILA core. We select the net for debug and go through the wizard with default options here. After using the wizard, we now need to save constraints. The corresponding XDC commands will be saved to the target constraint file and are used during implementation to insert and connect the ILA core. So in this design, we'll be overriding the existing constraint file, and all additional debug-related constraints are added at the end of the file. If that is not desired and you prefer to keep your existing constraint file intact, you can create another constraint file in the existing constraint set and make it the target. However, creating a new constraint set that contains this new constraint file will give you the flexibility to easily use separate constraint sets for different implementation runs. To save changes to the design to a new constraint set, select File, Save Constraint As to create a new constraint file in a new constraint set. Let's call this new constraint set Debug1. The new constraint set includes all design constraints, including all the changes. This is one way to maintain your original XDC source file. Now that we have made our netlist change at post-synthesis, which was adding an ILA to the design, we can create a new run to incrementally run place and route. To create additional runs, right-clicking the Design Runs window and select Create Runs. We name this run Debug1 Incremental and select Debug1 constraint set along with the same part. In addition, let's create another new run with the Debug1 constraint set just for the comparison to show the runtime for implementing the current netlist without incremental compile. This is just for demonstration purposes here and not required. Let's select Do Not Launch for now and click Next. You can see that we have 3 runs. First is our default reference run that had no debug core in it. Let's change its constraint set back to what it was. We're going to use the routed checkpoint from this run as the reference guide for our incremental run. In project-based flow, if we're pointing to a reference or DCP from an existing run, it's best to first copy it out of the project run directory and move it to another folder. This is so that if you rerun the original run, your reference is not modified. You can open the run folder and copy the routed DCP to a new folder. This is already done for this demo. Our next run is the incremental run that we need to enable incremental compile for it. To set that option, right-click on the run and select Set Incremental Compile. Here we point to the checkpoint or DCP file used as a reference for the incremental compile flow. We select the top routed DCP as the incremental compile checkpoint. In non-project mode, you use the read checkpoint tickle command with the -incremental option after op design to point to this file. And finally, the last run is our non-incremental run with ILA added that we would like to compare its runtime result with the incremental one. Now we're ready to run the implementations, and when they're finished, we can compare the results. Now that the runs are finished, we can see that the implementation run for the incremental is less than the one that is non-incremental. Note that this is a small design. The advantages of the incremental compile flow are greater and more significant with larger and more complex designs. Looking at the incremental reuse report shows the percentage of the reused cells, ports, and nets. A higher percentage indicates more effective reuse of placement and routing from the incremental checkpoint. In Tickle, you can use Report Incremental Reuse command to examine and report the similarity between the reference design checkpoint file and the current design. In summary, we learned about the benefits of using the incremental compile flow the recommended steps for debug using the incremental compile flow, as well as a demonstration of how to use these features. For more detailed information about incremental compile, you can look at the Programming and Debugging User Guide UG 908 and Implementation User Guide UG 904. Thanks for watching this Vivado Quick Take video.